Welcome back to our Intro to Solidworks video series. We've covered the user interface and beginning sketching on planes. We've created some basic 3D geometry using features. Now what we're going to talk about is sketch relations. We've touched on those about how SolidWorks infers sketch relations as you're sketching, but we're going to talk more specifically now about ones that you might add in additional to the inferred ones. So I'm going to start out by looking at a part I've created previously that I've shown you as part of an assembly. So let's open up this trainer assembly that we looked at before. And we'll look at a mounting plate in there. So looking down here in this corner of the trainer, you can see there's a little HMI interface, a touchscreen interface, and it is mounted to several 3D printed parts. It's mounted through a plastic plate that we cut out on the laser cutter at school. So we're going to recreate something like that. Now we're back here. So what we're going to look at is this plate right here. So you can see there's these 3D printed brackets that attach to the base plate on each side. This is a manufactured part, the interface itself, so it has fixed dimensions that can't change. But I've gone through a few different iterations of how to mount it. So this mounting bracket that connects between the device itself and the mounting legs, I've modified that a number of times. And so I think that's a good example of a really simple part, but it'll demonstrate how we can use sketch relations. So let's go ahead and open it up and look at it. And you can see there's just 3 features to create it. Basically, one sketch creates a rectangular ring with a cutout in it. Then I do some fillets to it to ease the edges, and then I added the mounting screw holes in the last one. So we're going to recreate that from scratch. So I'll create a new part. And while we're doing this, this is a good time to talk about units. So when you're in a new part here, it has a system of units, and you can always see what that is down here in the corner. It has some default unit system. So right now I'm in the inch, pound, second. So it's for length, we're looking at inches. For mass or forces, we're looking at pounds, and time is seconds. I can also choose meter, kilogram second, centimeter gram second, or millimeter gram second. Any of those are fine. That's one way to do it. You can also go to edit document units, and here you could set up custom types. And one thing that I like to do here always is in the mass section properties, I like to change the decimal places for my units. So I'm going to go to mass, we'll do millimeters, grams, seconds, and I like to have at least 2 or 3 decimal points of units for there. So I'll say OK for that and leave it in millimeters, or we can work in inches. Most of you probably more intuitively think in inches, but let's again go in there and change the mass properties to add some decimal points there. Okay. So now that I have my unit set up, I'm going to start by sketching. And if you think back to the orientation of how that part was in the assembly, I'll go back and look at it. I can pick, right, whether I'm going to sketch on a front, a top, or a right plane. And looking at it, hopefully intuitively you kind of think probably makes sense to sketch on the front plane, right? So in the assembly it's at an angle here, but in general its orientation is primarily horizontal. So back in my part, I'm going to start my sketch on the top plane instead of the front plane, because in general I'm looking down on it. So I'll sketch on the top plane. And I'm going to start by creating a rectangle, and I could do corner rectangles like we've seen before. So corner rectangle, you select a starting corner and then an ending corner, and that's totally fine. But as you can see, that's completely undefined as far as where it is location, right? So this is a good time to start talking about relations. If you look over here on the left side, you can see there's some add relations. You can also see that when I select an entity, it shows me the relations that have already been inferred. By this little green box here shows it inferred a horizontal, and over here it inferred a vertical. If we look at a point, you can see if there's any relations. No relations on there yet. I could select that point and then select the origin, and it now gives me some options over here. Do I want to make those points horizontal? If I do that, the box will jump up to where the origin and that point I selected are horizontal from each other, but I can undo that. I can also choose vertical, so it snaps to where that corner is vertically underneath the origin. I can undo that. Or I can say coincident, and that puts it so that the point I had selected and the origin are basically merged into one point, and I can undo that one as well. But if what I really want is for this rectangle to be symmetric around the origin, so both vertically and horizontally, I can do that a couple different ways. The easiest way probably is to float over the line here, and can you see as I move along the line, it automatically is inferring, hey, did you want to look at the midpoint of that line? And so if I click on that, now I've selected the midpoint. If I then hold down Control and hit the origin, now if I put those vertical, now you can see that it's symmetric about the origin vertically. Horizontally, it's still not. I can move either one up or down. So if I want to recreate that same effect vertically, I again can select the midpoint, select it, and now I would say horizontal. And now this rectangle, no matter how I change it, will be symmetric about the origin. Let's say now I want to say, I don't want it to be a rectangle, I actually want it to be a square. I can do things, relations that add that as well. If I select one of the horizontal sides and one of the vertical sides, and now look over at the relations that are available to me, one of them is equal. So if I click equal on it, now it's going to always make sure that the sides are of equal, so it's a square now. So I'll undo that because I want it to be a rectangle, and I'll undo all the relations. And actually I can always see what relations are already in the sketch. I can look at a particular entity by selecting it. So if I select this top line, I can see there's a relationship that top line is horizontal, and it also has a midpoint relation. If I want to look at all relations for the whole sketch, I can do that by up here in my command manager, going to display and delete relations. And now this shows me all of the different relations. And as I select them, you can see it highlights which one it is. So that's horizontal for the top line, horizontal for the bottom line, horizontal between the midpoint of this right vertical line and the origin, vertical, so the left line is vertical, right line is vertical, midpoint of this line is vertical, and midpoint too. So you can see those are all the relations. So if I wanted to delete all of them, I can do that, and now I'm back to completely unconstrained. And you can see that deleted both the vertical and horizontal, so now it's not even a rectangle necessarily, because I've removed all of those inferred relations that happened when I created a rectangle. So I'm going to delete it all together and just show you that that was showing a way to make it symmetric about the origin based on relations. But there's another tool that kind of skips some of those. I can click a center rectangle, and so now if I click on the origin, you can see it's inferring a coincident by that yellow square showing up. And then if I click on it, now it's creating a rectangle that is symmetric about the origin. So again, if I want to turn that into a square, I could just click a horizontal and a vertical and click on equal up here. And this is a good point to point out. It shows me what relations I can add over here. It also shows me those as soon as I clicked on the two things. It's showing me a context sensitive, all these relations I could do here. I can make them fixed, horizontal, vertical, collinear, perpendicular, parallel, equal, and fixed. And then we get into dimensions and other things. So just remember multiple ways to get to the same thing in SolidWorks. So I will go ahead. I'm happy. I just want it to be symmetric. I don't want it to be a square. I'm in inches. So let's say that I want my overall dimension of my panel to be something like 7 inches by 8 inches. So remember, I can get to dimensions a couple ways. I can select a item and it says, hey, do you want to insert a dimension? So I could do that. And let's say I want it to be 8 inches wide. Let's try a different way to dimension this one. Again, if you remember, you hold down the right mouse button and scroll up. That gives you the dimension tool. So I can dimension this one. Let's say this one's going to be 6.5 inches. Okay, let's look at what happens if I try to add a dimension to this line over here now. You can see it says, hey, you can't add this dimension because it would over-define the sketch. And that's because, so I'm going to cancel it. That's because the width between this line and this line is already set by this dimension, right? So it's saying you can add that dimension, but if you do, you're adding too much definition to the sketch. And it says, do you want to make this dimension driven, which means it's basically just an informational dimension. So let's go ahead and do that. So now if you look at these two dimensions, you'll see one of them is black. That's the one that's actually driving. And then this one is gray. That's the driven dimension. So if I edit this dimension to 7 inches, you can see that the driven dimension updates. And I can't actually edit anything on the driven dimension. Okay, the other option I could have done when I overdefined that sketch is I could have said, it gives me the heads up, hey, you're adding too much information. I could say leave this dimension driving, and now it shows the sketch is overdefined. So down here at the bottom it says overdefined. It shows that there's conflicts between these two dimensions. That helps when I see overdefined and I want to figure out why. I can go back in, and the yellow things are what are conflicting with each other. So now if I deleted this original 7 inches, now the one that's on the left that was overdefined, now it's the driving dimension. So I can edit it back to 6.5 inches. That's just a little bit more about dimensions and why it might say, hey, you're overdefining the sketch. So now I've created a plate that's 6.5 inches by 8 inches. Let's go ahead and go straight to an extrusion of that. And I think I created this out of 3/16 plastic. So I will do a blind extrusion that's 3/16 thick. I'll just put in there 3 divided by 16 and say OK. And now I've got my blank plate. Now I need to add the cutout for the device that's going to go into it. And I need to also add a series of screw holes to attach to the legs. So I will sketch on the face, go normal to it, and again I'll use, I'm not going to use a center rectangle this time. I'm going to use a corner rectangle because I might not want it to be directly centered on the origin in this case. So let's go ahead and add a rectangle, and you can see right now it's completely undefined as far as location. I can drag any corner anywhere. You'll note that while I drag it, it does stay a rectangle because it has some inferred relations that each of the lines is either horizontal or vertical. Again, let's watch what happens if I delete that horizontal. Now if I try to drag this corner, instead of being a rectangle, it lets me make an odd trapezoid kind of shape there. So I'll go ahead and undo deleting that relation. Go back one more to undo sketch relation. There we go. So now I'm back to where it's a rectangle that I can drag around. So there's a couple more relations that are useful to us. Let's start out by just dimensioning this. Let's say overall I know that the cutout for that device needs to be, let's say 5 inches by 4 inches. So I'll just dimension 5 inches. So you'll notice I got my dimension that time by typing in the letter D on my keyboard. So if I'm just normal pointer tool and hit D, it gives me the dimension tool. So let's say 5 by 4 inches. And you can see it's not centered at all right now. So let's say I want it to be centered left to right. I could do that a couple different ways, right? One of which is I know how wide this overall shape is. So this was 8 inches, I think, right? I can always check that by measuring. So go to evaluate, measure. And yeah, that length is 8 inches there. So one way I could center it is to put dimension off of the side. Oops, got it wrong. Do that again. So dimension to the edge. And so we were at 8 inches minus 5 inches, so that's 3 inches, and I want it centered, so I could say 3 divided by 2, and that puts it in the middle. So that's one option. And then let's say I want it to be centered. Actually, let's just do an offset. Let's say I want to make sure that there's always a 1-inch space at the top. Okay, and so now I can go to features and do an extruded cut, and that will put my hole. And here we could do blind of 3/16. Let's go ahead and leave it like that for now, and I'll show you another reason that I typically don't do blind on things like this. Let's say I go to cut this out on my laser cutter and I realize I don't have any 3/16 material. All I have is 1/4 inch material. So I'm going to come in here to my original definition of my plate, and I'll change that from 3/16 to 1/4 inch material. See what happens now? My cut was blind, and it was fixed, if I go and look at the features of it, at a depth of 3/16. So how I can avoid having that issue is, instead of doing a blind extrude, if I know that I want the cut to go all the way through the material, instead of doing blind, what I would do is go either through all. That means it's just going to cut through anything that it sees out there, and that's totally fine on a simple part like this. Or I can also, another option that I actually use the most is going up to next. And so it's going to cut through until it reaches the next surface of this part. And when you get into more complicated parts, you may see the distinction between those. Okay, so that's a little bit about the defining parameters of an extruded cut or an extrude, whether you go blind or up to next. Okay, so now I have my cutout in there. Let's say if I'm working in my assembly back over here and I realize that 8 inches is a little too wide, that I need to tighten that up a little bit. I can't have an 8-inch wide plate. Really, I can only have a 7-inch wide plate. So let's go back and edit our part to do that. So I would go back to edit the sketch of my original extrusion and say 7 inches. Okay, and update that. So look what happens now. Since I had defined the sketch for my extruded cut by a dimension, let's go look at that, a dimension off of the left side, it held that dimension, so now my cutout is no longer centered left to right. So let's edit our sketch using relations to make sure that no matter what size the original plate is, the cutout is always centered left to right in it. So I'm going to get rid of that dimension off the left side, and so now you can see that I can move it left to right. I can't move it up and down because I still have this dimension that's saying this top edge is always 1 inch off, and I've got a dimension saying how high the cutout is. So it's defined as far as up and down, just not left to right. So there's a couple different ways I could do this. Hopefully you're getting the sense of. Probably the easiest one in my mind is to find the midpoint, but you can do that by just sliding over. You can also select the line and right click on it and say select midpoint. It's another way to easily get it. And then I'll select the origin and say vertical. Now you can see my sketch is fully defined. I can rebuild it and it will stay centered. So now even if I go to the sketch here and edit my sketch and put it back to 8 inches, or let's do it something different. Let's do an arbitrary, let's say it's 9 inches now. My cutout stays centered in it. Okay, so we've used the vertical, the horizontal. Let's start looking at our screw holes that we need to add into it, and that'll give us some more relations that are useful. So I want to add some screw holes. And you can see as I'm drawing here, it's trying to infer relations, and that's fine, but I'm just throwing them out here kind of randomly in size and space, and then I will use relations to create symmetry about it. So anytime you're doing bolt holes, often it's in a pattern that you want to have symmetric. So we're going to look at some relations that help us with that. Okay, so first off, you can see they're all different random sizes. So I'm just going to select all of them, and I used previously that equal one, so I'll make equal here. Another useful one that we'll talk about in a minute, you can see when I've selected circular shapes or arcs, there's a bunch of different relations over here than there were when I was looking at line features, right? So I have co-radial, concentric, equal curve lengths. So you can see it's the available relations depend on the type of entity that you're working with. Okay, so I've made them all equal, but I still haven't said what that equal size is. So you can see if I grab one and try to change it. So I'll dimension one of them. Let's say I want the mounting holes to be 0.125 inches. Okay, so they all snapped to be 1.25 inches in size. But you can see I can still move them, any of them, wherever I want because there's no geometry. So a couple different ways to do this. Let's say I know, how should I say this? So before, for this central cutout, it is a fixed dimensions to match the device that I'm mounting in it. Now, rather than having these screw holes be relative to the origin, like symmetric about the origin, I want them to always be spaced the same distance off the edges, because I might change the shape of the panel, but I want the legs and the mounting holes to always be a fixed distance off of the edge of the panel. Hopefully that makes sense. I wouldn't want to change my panel shape and have the legs line up, you know, an inch in from it. I always want them out there at the edges. So I can do that. Again, there's lots of different ways to do it. One of the easiest ways is to define one of them. So I'm going to dimension off of a top edge. Let's say I want it 3/8 of an inch in. So I'll say 0.375. And I want it 0.375 in here, 0.375. So now I have that one where I want it. Here's a way I can make things symmetric, is to add center lines. We use those a lot of times when we're mirroring things or creating symmetry. So I'll add a center line that's vertical and one that's horizontal. And actually, I'm not going to do them on the origin, since I can do them about the origin in this case if I really wanted to, since my overall original sketch was about the origin. But just to show you that you can do a center line anyways, what I really want to make sure is that these bolts are always symmetric about the edges of my outer dimension. So I'm going to create a center line that's off of the midpoint of one of those, and another center line that's off of the midpoint of one of the horizontal lines. Now what I'm going to do is select that center line and the object, that object there, and this one over here. And you can see now, down in Relations, I have the option to make them symmetric. And let me show you that. So I'll click Symmetric, and this one over here on the right now automatically jumped to be symmetric, or a mirror basically, about the center line from the previous one. So if I delete these dimensions that are defining where this one is over here, it will still remain symmetric. These two will still be symmetric. So see, as I grab and move that one, now it's mirrored about that. So it stays symmetric even if they're undefined. I have symmetry about that line. So let's go ahead and just redefine that one, 0.375 and 0.375. So they're symmetric now across, about this vertical center line. And now I'm going to create similar symmetry about this horizontal line. So I'll again select one that's defined where I want it, what I want to create the symmetry about, and the one that I'm trying to create symmetry. So now they're symmetric. And this last one now, I can do a couple different ways. I could again do symmetry. I can just do that, select a mirror line to mirror about and create symmetry, and do the same thing. So it's now symmetric horizontally, and you can see everything is fully defined now. They're all black. So I can go ahead and do an extruded cut. And again, rather than doing blind, I'm going to say through all or up to next. And now I have my mounting holes. So you can see, let's go ahead and edit my original sketch again. And let's say from 9, let's come down to 6.5 inches. And rebuild it. And we'll see that my center cutout stayed centered in the plate, and my holes did not. They're stayed relative to the edges rather than relative to the origin. So you can see now I could update the outer dimensions of the plate, and my holes will always update based on the outer dimensions, and my inner cutout will always be related to the center origin of the original plate. I think that's a good first overview to sketch relations. Again, the most common ones you'll use will be vertical, horizontal, midpoint, coincident. Oh, let's look at one other one that's related to circles. Let's say I wanted to add some counter bores to these through holes. So I wanted to create a little pocket, basically, that the screw head would be down inside instead of being up on the surface, because that'll let me use another handy one called Concentric. So I'm going to sketch on the face of it, go normal to it, and now I want to add these circular pockets. So I could just go and sketch my circle, if I kind of float over the middle, you can see it's inferring a coincident to the center point. I could do that and it'll create a circle that now if I try to drag the center of it, I can't because it inferred a coincident there. The center point of the new circle is coincident with the center point of the previous cut through. I can still drag the outer size fine, but let's say I didn't do that. Let's say I just drew my circle randomly out here, something like this, and I want to make sure that it is perfectly centered over my previous hole. Again, I can drag that one over there and find the middle point and they go coincident, but another way that's often more handy is just to select one circle, the other circle, and then see here this one that says make concentric, and see what happens when I do that. That takes any circular feature and makes their center points coincident. So now I have a circle that is concentric about that one. So I can go ahead and do that for, just create some other ones out here. And again, this isn't necessarily the best way to do this, but it's just a way to show you how to use concentric. So select these, each of those, make them concentric. Same thing down here. Oops. Concentric. Concentric. Okay, and then I can select all four of them again, make them equal, and then dimension them. Let's say I want them to be a 1/4 inch pocket. So they're now, and now you can see my sketch is fully defined. Everything's black. Down here it says fully defined. So I'm going to go do an extruded cut. And rather than doing through all, I just want these to be a little pocket. Let's say I want them to be a pocket that's 75 thousandths deep. So I'd say that and say OK. And now I have created some pockets. And let's go ahead and edit my original sketch again. So if I edit my sketch and make this, let's go say 7.5 inches and oops, wanted that one 7.5. Let's make this one 6 1/4 now. And rebuild. We'll see that my mounting holes moved and the pockets that were made concentric around the original dimensions, they followed where the cuts made because they were based on concentric to that original. So basically my sketch 4 is based on being concentric to the circles from sketch 3. Okay, that's an introduction to sketch relations. I encourage you as you're working in a sketch to always be paying attention to what does the context sensitive menu pop up as far as options for it. So if I'm sketching on this plane and I draw a line and I want to look at different things I can do with it, just start selecting different things. So I could make this line collinear. That's another really common one that I guess I didn't talk about. That just means it's going to automatically bring the line up to be exactly collinear with the previous line there. So let's click on that. And you'll see I can still change where the endpoints are. It doesn't mean it has to be coincident. So it's not stacking the line right on top of the previous line, but it's saying it is on the same line if you extended the line into infinity. So collinear is another really useful one. Another one, if I draw another line out here that we don't use as often, but you definitely can, is the fix, the one that looks like an anchor. That just locks everything about that in place right where it is. And we don't use that one very often because if you think about it, that makes this line kind of unuseful as far as being parameter based. You're not going to be able to change things in the future. If you fix that line and you fix its endpoints, it's never going to update. You can't change anything at all. It's always just going to be exactly where it is. I can't drag anything. If I dimension it, it'll say it's overdefined because everything is fixed there. Okay, we'll call that good for an introduction to sketch relations. Anytime you have questions about relations, you can always come up to the help, type in relations, and it'll give you all different types of relations there. Tells you what ones are available to you, depending on whether you're in 2D, 3D, etc. Oh, one thing I also wanted to, while I'm in this video, talk about, because you'll use it in this week's problem, is that mass properties feature. So right now, my material for this piece of this mounting bracket that I made is undefined, right? It's not specified. If I want to edit that, I can, oops, sorry, that's not what I want to do. I want to choose a material. So let's look at it, the one there. So I can do, let's look at steel. I'm really making this out of plastic though. So let's say, so I want to select a material, and oh, it's not, let me select, oh, I'm still in a sketch. So I need to get out of this sketch, and then I'm going to choose my material. So I say edit material, and I'm making this out of plastic. So I'll close the steels and look for plastics, and I'm using acrylic. So we'll just select acrylic, and you can say what unit system. So right now I was doing inches for my length, so I'm going to look at it in English units and say apply. Okay, and then close that. And now over here you can see it says acrylic. You can also see it looks different because it knows that acrylic is typically clear, so the appearance of it has changed. And we'll do more with dealing with changing appearances in the future. But what I'm really talking about right now is changing the mass properties. If this plate was made out of steel, it would weigh very different than if it's made out of acrylic. So we can always look at the mass of the part by going up to evaluate and looking at mass properties. That's definitely one way to do it. So you can see it's 0.29 pounds using that plastic. But if I want to be able to always see what the mass is, there's this useful thing called sensors here. So if I go to add a sensor, I can say I want to add a sensor based on mass properties. Yep, that's the type of thing I'm looking at, and I want to know the mass of it. So basically the default one, and I say OK. It now adds in something that's always showing me the mass of the part. So let's say I change the part. If I come down here to my sketch, so right now it weighs 0.29 pounds. If I change that sketch to make this bigger, let's go out to make this, let's say 9.5 inches. Rebuild the part. My weight's going to change, or my mass. So instead of 0.29 pounds, now it's 0.43 pounds. So that's an easy way. If I'm asking you to show me the mass of a part, and I just ask you to give me a PDF of the part with the mass properties in it, that's an easy way to do it, because you can have the part showing right here, and off in the side here you can have mass shown as well without having to have the mass properties window open. So another useful thing, you can always change the decimal places if you need more accuracy. If I ask for it more accurate than 2 decimal places or something, you can always do that there. For changing the decimal points in the sensor, that's the document properties. So I would need to come down here, edit document units. We did this before. So again, at mass section properties, I could go up to 3 decimal points here, and then that should update my sensor. Yep, and so it went to 0.426 pounds. Okay, just a helpful little tip about using sensors to look at mass. Again, let's say I wanted to also know the volume of the part. You might play around with looking at the different sensors available to you. So the volume of that is there's 9.82 cubic inches of plastic available. And if I change the material to steel, so let's go, instead of plastic, I wanted to see how much my part would weigh if I made it out of steel instead. I can say apply. You can see it went from 0.4 pounds up to 2.8 pounds. So, and you can see the appearance changed as well. Okay, enough for today about sketch relations and using sensors to show you mass properties. I hope that's helpful. Stay tuned for our next video.